Formic acid takes its place and becomes phenyl ethyl formate. Acetate comes from vinegar. So what would phenyl ethyl acetate smell like? Fruity rose. Who knows what phenyl ethyl acetate smells like? You know it? It smells like a fruity rose. Yeah. The next one up is propionate.
So the 3.
Sorry?
Yeah,
C3, sorry. 3 carbons, yeah. So propionate from propionic acid is a little bit sweeter than the acetate. So phenyl ethyl propionate is less fruity and a bit sweeter than the acetate. The next one up is C4. Butyrate. Butyrate is from which acid? Butyric acid. Does anybody remember from day one what group butyric acid falls in? The ABCs. In the dairy, yeah, because it's a buttery or a cheese-like smell. If you get cheese and you leave it in its packet in the warm, it gets that horrible yellow liquid around it. Very high in butyric acid. Yeah, that's the character of butyric acid. So what does phenyl ethyl butyrate smell like? It's more sort of creamy, a sort of a creamy rose, yeah? A sweet, fruity, creamy rose, yeah? Valerate. Smells, it becomes milky and a little bit winey, sharp. So phenyl ethyl valerate is a sweeter, fruity, a bit creamy, but a bit like sour cream, more like sour cream than the butyrate. Some of our functional groups are rings from salicylic acid. Salicylic acid, what group would that likely to be in? Sorry? Medicinal, close, one letter down. The orchid, yeah. Yeah, the salicylates give you, it is a medicinal smell, yeah, but it gives you this orchid character. Now, if we look back at the bodies, so salicylate has this orchid character. And if we look back at the bodies, some smaller bodies, the smallest body we can get is methyl, which is a little bit like that formate. It's a little bit dry. It's a little bit harsh. Methyl salicylate. So who knows what methyl salicylate smells like? Harsh orchid. But actually we know it as wintergreen. Wintergreen or methyl salicylate, used in tiger balm, yeah. Used in counterpain, yeah, that's methyl salicylate. Sports injury things, yeah. So that's very harsh. It's harsh because we have this big functional group compared to a small body. So here we have like big arms with a very tiny body, 1 carbon, yeah. If we go to ethyl salicylate, which is 2 carbons, I think it's 8. Yeah, 8 carbons. So it's comparatively. Don, you're the chemist. Salicylate, how many carbons? Okay, we'll come back to you. We'll confirm. Yeah, I think it's 8. Okay, so methyl salicylate. So ethyl salicylate. That body is now a little bit bigger. Ethyl alcohol compared to methyl alcohol is sweeter. So what we have is counterpane, but a little bit sweeter. Yeah. Ethyl, ethyl, butyl. We never see the third one, but fourth one is butyl salicylate. Yeah. When we get to butyl salicylate, sorry? Is the functional group. It's because it's from salicylic acid. Salicylic acid is the stuff you put on warts and corns to melt them away. It's a white paste you get from the pharmacist. Yeah.
Sorry, how did you describe ethyl salicylate?
As a slightly sweeter version of the methyl salicylate. So it's a bit sweeter than the counterpane. When we get to butyl salicylate, what happens now is the orchid character starts to become obvious as a floral note. Yeah? So this now becomes like a fresh orchid. Butyl has a slightly milky, fresh character. When we go to C5, amyl salicylate, it's now becoming more and more floral. Yeah. And then we come to this really interesting one at C6, hexyl salicylate. And hexyl, yeah. Does anybody remember the name cis-3-hexanol? Which group was that in? In green. Yeah. Hexyl, whenever you get hexyl in the name, it's always green. So what we have here is we have like a green orchid character. And it's like the top note of an orchid flower. It's like it's got the greenness as well. Okay. I've never actually seen it. I've never seen propyl salicylate. So yeah. Sorry? Propyl, propyl, propyl. Propyl, yeah, sounds a bit. Now, there aren't that many words to remember. So what we have on the next 2 pages are a table of words that will cover probably 90% of the aroma chemicals you will come across. So if you have the chemical name, yeah, you can predict what the smell is likely to smell like. Yeah? Now, if you've read The Emperor of Scent, yeah, you'll see that it's a battle between, you know, not good and evil, but Dr. Luca Turin, yeah, and the establishment, the perfumery establishment. The perfumery establishment is represented in the book by Charles Sell, who is a big proponent of the shape theory. Yeah. I've met him, he's a very nice guy, yeah, but he's very, very traditional sort of, yeah, yeah. Stubborn. Yeah, yeah. But then I'm stubborn, so. I forgot what I was going to say. Where was I? Sorry? No, he didn't do the course. No. I've not much. Yeah. Yeah, that's another story. But where was I? So you have a table here, yeah, of what names and what the smell is, what the molecular weight is, yeah. So what we'd like you to do is to go through a range of aroma chemicals. The sheet we hand you out will have the names. And what I would like you to do is to look up and predict what the smell would be. So you have to take into account the size of the molecule, does it have an OH group on it, an alcohol group on it? How big is that alcohol group compared to the rest of the molecule? Yeah. Its function, its body. Is it a specific structure? So you'll have phenol, but then you'll have phenyl ethyl or phenyl acetate. So check there isn't. So once you've found phenol, make sure there isn't a phenyl ethyl. Yeah, and then compare that. And then check the functional group. Yeah, and then what you do is you write down a description based on that. So if it was a small molecule with an OH group, you probably have the word something like soft. Yeah, to start it off with. Yeah. Oh, I remember what I was trying to say when I talked about Charles Cell is actually what you're doing now from the current thinking about shape theory is impossible. Yeah? So if it works, it points more towards vibrational theory. But there is a shape factor that comes into it because if the molecule is too big, it can't attach to the receptors. So there is a certain amount of shape that does come into it because if a molecule is too big, it never gets to your nose. Yeah. The best way to deal with these is to pull these sheets apart if they're attached. Yeah. Yeah, yeah. So, is everybody clear about what to do? Yeah. What you do is go to the white sheet. Yeah. You see the group A. Read the names. Look up on the two sheets with the coloured bands on them. The bodies are shown in blue. Is it? In blue. Yeah. And the functional groups in red. Pink. Yeah. And you'll see that there are some things with dots there. These are things called isomers. I won't go too much into that, but there's some effect on the smell, but generally the character of the smell doesn't change that much. It's a different type of smell, different tone, but basically the smell is similar. Yeah. So the first one is aldehyde C8. So in brackets there it says octyl as well. So you want octyl aldehyde. Yeah. So if you go down the column of the blue, look for octyl. What does octyl smell like? Hard citrus. And aldehyde? Harsh chemical. So harsh chemical citrus aldehyde.
So with the molecular molecular weight, would you add up the two then?
Yes, so you add up the two to get the total, total molecular weight. And does it have any OH groups? No, no. Yeah, so that means it'll be fairly strong. Yeah. Has an OH group, it will become softer.
Solubility?
Solubility, does it have an OH group, a hydroxyl group?
Steve,
Yep.
you in the predicted smell, you mentioned 10% in DPG.
Yeah.
That's just going to dilute it.
Yes. That gives you a clue. It gives you a clue that it's probably a strong material, yeah, or it's a solid material, yeah.
Can I ask a question about the, where you've got here with the body, the C carbon,
Yeah.
so presumably you have to take that into account with the aldehydes?
Well, the C8 actually means the same as octyl.
Oh, it does, okay, so
Yeah, yeah.
that's, you wouldn't add that.
You don't need to add on that. Yeah. Yeah. No, just those A to A, all the way, that 5. Yeah, just those 5. No, because then you'll smell them and compare. Is it really like that? Yeah. No. So we're going to do it now. So as soon as you finished A, yeah, put your hand up and then Ryan will give you the materials and then compare to your prediction. Yeah. Mức hào dụng mưa. Rock out.
Quick question.
Yeah.
What would you use this kind of knowledge for?
Because if you go to a perfume house and you start to learn raw materials, after 10 years you may know 1,000 materials.
Okay.
If you learn this system, you'll know 1,000 materials within about 2 or 3 weeks.
Okay.
Yeah. So.
And how do you guess between, because C9 says citrus fatty,
Yes.
C10 says fatty citrus. So how do you know how to define them better? It'll be more fatty, that'll be more citrusy.
Okay. Now, really, really important for this is there are no words to explain smells. Yeah. Only smells can explain smells. Yeah. So the purpose of this is to catch what the difference is between C9 and C8. But the reason that the other way around is that it's more fatty than citrus.
Yeah, like
As
I
it gets
said,
bigger.
C10 will be more fatty than C9.
Yes. Yeah.
And this is orange and lemonish. So this is going to be more on the orange side and this will be on the tangerine side. The fatty citrus.
Yeah. More orangey and less. Yeah. More orangey, actually.
This is going to be a little more
Yeah.
tangy
Yeah.
and more sour.
And actually, this is the component that's responsible for the smell of oranges. C10. Oh. one of the purposes of this is remember there are no words to describe smells. Yeah. Yeah. The idea is to catch the idea of what C10 smells like, what aldehydes smell like, and then they become like building blocks you can put in your mind. Oh, phenylethyl is rose. Yeah. As soon as you got it, put your hand up and they'll give you the materials, yeah. Yeah. Compared to yeah, yeah, otherwise it gets too smelly. Perfect. Oh, what's that? You know, I was just smelling the CO. So, oh, okay, maybe. Not ready yet. You get this? Yeah. Does it make sense? Okay. but please, important point of this exercise is that there are no words to describe smells. Yeah? Smell are not words. Smell is, yeah? And the idea is to get what aldehyde smells like, what C10 smells like. Because once you get that, you can almost, when you see a name, the smell jumps out at you. Yeah? You don't have to like do if you're physically writing, yeah, fresh chemical. But once you get what C8 smells like, has a particular type of smell. So if the that C8 chain is in a completely different molecule, it's like, I can sort of smell that influence. So there are no words for smells. Yeah? Words are just signposts towards the smell, just to give you a clue of where you might find it. Are you ready? No. Okay. So do that block. Okay. Yeah, do that block of A. Yeah, and then we'll give you these. Okay, you've done the 5, so you can. So C8 to C12, and then compare to what you got. There's just one set because it gets really strong otherwise.
Pretty good, well, really good, except the rose one was a bit.
The rosy one?
Yeah, it wasn't quite.
No, it's like a fat. It's like the wax on a rose. Think of a wax on the rose. Yeah, It's not. Yeah, yeah. I don't think I said it here, but remember, there are no words to describe smells. No, I don't mean that. What I mean is that smell is a smell. It's something you have to conceptualize yourself. So what does aldehyde mean? So nowadays, yeah, when I see a name aldehyde in something, I have a specific sort of character that aldehyde is. I can try and explain it to you.
But
until you get it, yeah. And the purpose of this is to try to get you to like start to think, Oh, acetates are this sort of sour, sort of sweet character. Butyrates have this like buttery character, and yeah.
You know the Emperor of Sin?
Yes.
The most interesting part of that was when he cured the woman who smelled bad smells, the Scottish lady.
Yeah.
With the, he worked out, he gave her epilepsy drugs that would cure her. Remember that part of it?
No, I don't remember that part.
That
Oh.
was amazing. He just worked it out. Yeah, no one could cure it, but then she beat all the neurologists
Yeah, yeah.
and years later throw specialists around the world. There was a loop missing in her frontal cortex.
Cortex and yeah.
It's cool. It's a good book.
Yeah. I mean, I loved it.
I've got a couple of more ones coming when I get back. I'll be.
If you do the professional course, we show that it mentions the Horizon program that launched it.
Yep.
And I was like, not working on the theory of smell so much, but I was working on a system of smell. Yeah.
At the time.
And when I saw it, I like cried because it was like, oh no God, yeah.
I just, before I came over, they had a really good thing on Sky Television at home. It was an English production. It was a 4-part miniseries on the perfume industry.
Oh, BBC.
I don't know.
Yeah.
It was really interesting.
Yeah.
It started off with
Givaudan or something. Yes,
and
the
guy
school.
who was racist.
Yes, yeah.
And it came through, so I saw it.
Yeah.
Recorded it all.
Yeah.
It was good timing.
Yeah, good.
Yeah. Another song.
I mean, I have that original Horizon program, but I did a tape on VHS.
Yeah.
So it's pretty bad quality, but we show it sometimes in the next 2 weeks.
Yeah, I'll be doing it sometime.
Oh wow, this is so romantic.
Well, he was deciding whether to jump or.
Metaphor. I think they want to project that into the
Any idea when first one's coming up?
Friday.
Friday or today?
Well, no, my email said I think he was coming in on Thursday.
But he stays in this hotel.
No, I don't know. I'm not,
So Friday he comes here.
but Friday, I understand he will come here. Yeah.
Is he giving a talk or something?
No. It's just to view, just as a viewer, an observer.
All day or?
I don't know. That's up to him. I don't. Yeah. I invited. I said, "Do you want to give a talk?" Yeah.
He said no.
He said, "Yeah." I think he's pretty exhausted from his travels. So.
Well, I think he
Realize.
comes in today.
Yeah. Oh, okay. Yeah. Are you based in the UK now? Or?
No.
Okay. I'm on there.
Going on with the aromatherapy now? Or?
No, we do that tomorrow.
Oh, so today is what? This stuff?
Yeah. This is the main. And then this afternoon is structure of perfume.
So, to me, the aldehyde C8,
Yeah.
according to the thing that I've looked up, it's harsh, powerful chemical citrus. To
Yeah.
me, it smells like coconut.
Yeah. If you look up octolactone,
Yeah.
look up octolactone.
Lactone is
Lactone
Yeah.
or
Look,
coconut.
coconut. Yeah. C8. The C8 has a coconutty character.
yeah.
And this is why at the bottom of the sentence is, there are no words to describe smells. It's once you get that idea of octyl, what it is, I can describe it as metallic, I can describe it as coconut, but it's not that either of those. It's a smell.
Yeah.
And once you get that idea, like, it's like this octyl thing is like metallic, coconutty, and then when it's got like the lactone, it becomes really coconutty. When it's with like in a terpene structure, it becomes really like metallic.
Okay.
Yeah.
Yeah.
And you get this idea of how.
So you're not going to be able to just look it up and go, okay, that's what it smells like. You've got to kind of work out your own version of that as well.
Because the words are just signposts.
Yeah.
Yeah. The real meaning is the smell.
Yeah.
There are no words to describe smells. Yeah. Thank you. Oh. แต่เอานี้ไหมอีกชั้นหนึงโอเคเอาผมบ่อยก็ได้พ่อนคุณจะขอชั้นสีฟ้าชั้นหนึ่ง
อ๋อเอามาแล้วเอาอีกเหรอคะ
ใช่เราขาดหนึ่ง
เมื่อกี้เอามาให้
เอา
หลายอัน
เอาคุณให้แล้วโอเคไม่เห็นเราเขาเก็บเองโอเคขอบคุณครับRyan มีอะไรอีกไหม
อ๋อจะเอาโน้ตบุ๊กอะครับของลูกค้าที่ไปซ่อมเมื่อวานที่พันทิพย์พอดีเขาซ่อมมันต้องรออะไหล่มันก็เลยนาน
โอเค
ก็เลยเดี๋ยวให้นคร
โอ
ไป
เค
เอา
โอเคYeah. Coconut. Okay, so words are only signposts to the smell. All right, it's not the smell. Now look up octolactone. Yeah, gamma octolactone. So on your tray and in here. Octolactone. What am I looking for? Lactose, lactone. Coconut. Yeah. So that octa is sort of metallic and citrusy and also coconutty. Yeah. So when you get the idea that octa has this metallic, come coconut, come it's something in your mind. It's something in your mind that says you see it and you're expecting this sort of this character. But depending what it's with, so lactones have a milky character, so they make it definitely coconut. If you put this into a citrus compound, it would smell like lemon. Yeah. Octolactone.
Okay, we're working with octaldehyde.
Yes, yeah, but the whole point of this is that these are building blocks.
But then how does the lactone come into it? What's that chemical?
The lactone is it's a special, if you like, the functional group. Lactones are milky. Yeah.
What is that chemical called? What is it actually?
Oh, this is aldehyde C8. Yeah. What?
But shouldn't lactone be part of the chemical name?
Yeah. Well, no. This is not aldehyde C8. This is not octolactone. This one. This is octylaldehyde.
Octaldehyde, right?
Yeah.
But now, where does the coconut come from?
Because this C8 structure, depending on what it's with, sometimes it's metallic. Yeah. Basically, for me, it's metallic. Yeah. That's a word. That's not a smell. Yeah. But basically, for me, it's metallic. But when it's with the aldehyde group, it's sort of more citrusy. When it's with a lactone group, which is a milky note, it becomes coconutty.
So what's in the strip is actually octolactone.
No. Octylaldehyde. Yeah.
But it's not citrus. It's just smells like C8.
Yeah.
It's just that smelling.
Sometimes it will smell like citrus to you, and sometimes it will smell like coconut to you. Yeah.
This one, right?
Yeah. But this is the hardest concept of this here is to forget the words. Yeah. You want to tie it down to a word, but you can't tie it down to a word because it's a smell. That octyl is metallic. It has this like steely character, has this slightly hard character. Yeah, that's the part of the molecule. But when the aldehyde group comes on it, it comes sharp, makes it really powerful and sharp. Yeah, it's more citrusy. But normally people don't come to this coconut, so I think it's something in this group they've noticed the coconut character and they've focused on it, and they can't smell the citrus anymore. But so the aldehyde comes along and makes it really lemony, But if you take that away and the lactone is there, then it's milky, coconutty. Yeah, yeah, but yeah.
So, should we be trying to memorize? If we know the chemical, we should be able to remember that smell.
Well, that's right. What the idea is that if you know what menthol is always cool and fresh, yeah. So, what
if you create something and you want, you remember what the menthol smells like, and you think, yeah, I can do with a bit of that in there.
Yeah. Yeah, and for example, let's say you wanted something like this that we did with rose, phenyl ethyl acetate. Yeah. You put it into your rose and you think it's not like waxy enough. It's not creamy enough. Oh, maybe the butyrate will do it. Yeah. Yeah.
In other words, know your ingredients.
Yeah, but if you do the traditional way, you go and it take you 10 years to learn all the materials, 22 years to learn all the materials. Yeah, I mean, you're always learning them. Yeah, but if you get these concepts of these groups and what that part of the name does,
It makes it easy.
well, you can do this in 2 or 3 weeks. You know 1,000 materials in 2 or 3 weeks,
Yeah.
because phenyl ethyl, that's going to be rose.
Okay.
Lactone, that's going to be milk. Yeah. Butyrate, that's going to be a bit buttery.
Yeah.
Acetate, that's going to be a bit sour.
Yeah.
Yeah.
Okay.
And then
it narrows it down. Okay, you need a butyrate because of those.
yeah,
So you don't have to look through a database of thousands of chemicals.
that's right.
Okay.
Yeah. And what ends up happening, you see a name, and you can smell the name.
Yes.
Yeah.
Perfume glycol.
Sorry,
Perfume glycol.
I've confused everybody. Oh. Yeah.
Where is camphor?
It's not on there. Isn't it? Borneal is there.
O'Neill. The one underneath BI, by.
Oh, yeah.
Benzo beta by.
I'll say, so if you like to add a note of camphor as being cool, camphoraceous, slightly damp. You missed it. I must say, no, God forbid.
O'Neill's there,
Yeah, Borneo's there.
but it says Bon. It says benzo beta by Bon, and then you need to change it to an OL group. So then it's O'Neill. Yes, ma'am.
Okay, camphor. Thank you. That's just and eucalypto. So eucalypto will be just cool. Yeah. So so the Borneal is in Borneal. YL. Yeah. Yeah. I know why this has happened because I'm trying to get it onto 2 pages.
Oh, right, so that's not on here.
So yeah, the camphor and the eucalypto apparently are not on there. So yeah, sorry about that.
So Borneal,
Yeah,
so that's Borneal,
Borneal.
and the E-ol? What's the E?
Alcohol.
Alcohol. Okay,
Yeah,
so
think
the
about
E,
alcohol.
So the E just is
It connects it, yeah, that, yeah,
So
yes,
it's
yeah.
got to be alcohol.
Yeah, Borneal.
Alcohol.
Yeah, yeah. So it'll be a softer. Yeah.
So the presence of OH makes it softer.
Yes.
So, with OL, is it soluble or not soluble?
Soluble. Soluble.
Because it's in the alcohol.
Yeah.
Because it says no.
No, it's actually
Because it's a body.
no, because that's the group. That's the body. The body's not.
W and then OL.
Yes, yeah, yeah. Slightly soluble. Very, very slightly. Yeah.
OH is a functional group, right?
Yes.
So how many functional groups can be there in one body?
I don't know what the maximum is. I mean, it's as many connections as possible.
But then how do you know how much soluble will it be in water?
So oh, because if it had more than one alcohol, it would probably say di-alcohol or di. Yeah.
No, besides
But-
that, it's like, like you said, if we know there's an OH group, we know it will be soluble.
Yes, but if the body is big.
How soluble?
Oh no, that's
That's we don't know.
yeah, that's a whole other theory, but essentially very small, because there's something else I haven't discussed. Where, like I said about shape, does come into it, because if you imagine like theoretically, if you have something like that, yeah, that OH is very accessible. But then in another type of structure, yeah, Winnie, yeah. If it was there, then it's not as accessible.
But why is that?
Well, because it's got to touch receptors. Yeah.
So, if it's a closed body with a functional group, it's more accessible to you.
Yeah, or even a chain, that's more accessible. Yeah.
This you said is the most accessible.
Yes, yeah.
Followed by this and then
Yes. I mean, I'm actually trying to think of a chemical where I can demonstrate it better, but this, if the molecule sits on there, but the OH has to sit up there, then it doesn't have the same effect. But yeah.
Steve, can we look up
Menthol. Menthol.
And what's O-N-E?
Yeah, cool, fresh, light chemical. Yeah.
what's the ONE?
Look up at ONE. Oh, what have I done? Okay. Yeah, there it is.
Oh, the
Sorry.
ketones.
Yeah. You know what I said about space?
Yeah.
So I'm trying to,
Okay, so this is the ketone.
maybe, yeah. This is the ketone.
And OL is the alcohol. Right? Or what do you call the alcohol? The term for OL, just alcohol or
Sorry?
the OL?
OL is alcohol, yeah, so OL.
He's having a good day.
Okay.
Can I ask a question about going back to the coconut thing? Methylatone is coconut. Sorry, not a coconut smell.
Yeah.
Where would that be? Like the L-A-I-T?
Oh, no, that's their,
Is that
it's a
shortened?
trade, no, it's a trade
Right, okay,
name,
so
it's a
that
trade
wouldn't
name,
be
yeah,
the
no,
chemical name
yeah.
to it. Okay, so you need to find
Yeah,
out
yeah,
what
for the
full
chemical name is,
name
yeah.
and then work
Steve,
Yeah.
we've got some hard work, mate. We've got some hard work.
Yeah.
We've got someone who can't smell menthol crystals.
Really? Okay, look,
No, this is camphor.
Eat one.
eat one.
Eat one. Then you'll get the smell. No, you can eat it. We'll all do it. We'll all do it.
I'll show you. It's not coming out. No, I wasn't going to eat. So you take one crystal. And then,
Seriously?
Yeah, you can eat.
This is camphor.
oh, it's camphor.
You're eating camphor powder.
Cheers. Nice. I thought that's why they were sticking together. Menthol crystals come out like that. Yeah. I should have spotted it. Okay. Take a little bit, yeah. Chew a little bit off the end.
Menthol crystals. Not the camphor powder.
Not the camphor. Thanks for that.
I didn't give it to you. I didn't give it. Sorry, mate. I'm sorry. 20 years in the perfume industry, and you can't tell
Can't tell the difference.
between camphor powder and menthol.
Didn't.
I'm a fan of Borneo.
Really?
I like it. Good smell.
You like tiger balm?
Not so much.
Oh, okay. So-
I like, this reminds me of like a mountain hiking.
oh, I see. Yeah, 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 yeah.
Good outdoors.
Yeah, because it's got that sort of the woodiness, a bit of forestry in it as well.
Good. Do you use much of that?
Not a lot in perfumery, mostly in. Well, aromatherapy is not really allowed because it's synthetic.
Right, or sports rubs.
Sports rubs, tiger balm, yeah, and then Thailand they have their like
Have you put
varieties of
that
it.
in the proofing when it works?
We used small amounts. Gives like a rosemary type character to things, but a lot cheaper. Yeah. So you know, if, like in a perfume, if you want to use rosemary, but it's too expensive, you use eucalyptus and a little bit of Borneo.
Same
Yeah,
thing.
yeah, yeah.
Should we just carry on down the list?
Yeah, carry on down the list. We'll take a break half.
Okay.
Yeah.
When you do menthol, it's menthol plus the OH group.
Yes.
Right? So OH is defined as mild floral.
Yes.
How does it come into play in menthol?
Because we don't actually have a menthol aldehyde to compare it to. But if you had a menthol aldehyde to compare it to, then you'd see the difference. And I give you another example, amyl alcohol. Yeah. We smell amyl acetate, yeah, ethyl amyl acetate was pretty, but amyl alcohol is really, really strong and really, really choking, yeah. But if you've got the aldehyde, it's like 100 times more. Sorry?
What's an aldehyde again?
It's a CHO group, yeah, and it.
Use that for what?
Well, if we talk about aldehydes as a group, yeah, what we're talking about called aliphatic aldehydes, straight chain aldehydes. These are the ones responsible for Chanel No. 5.
Milky, soapy, all of
A bit soapy, like Lux soap.
Right.
Yeah.
In terms of soap, it will be Lux.
Yeah, yeah, yeah.
Dove, what about Dove?
Sorry.
Dove.
Still has a lot of aldehydes, but Dove is more creamy, more, and they put some pheromones in there which make it really awful.
But you know, so if you just smell menthol, there's no mild floral or anything like that.
No, it's just softer, cooler smell.
But to know if it's soft or not, you'll have to compare it to something which we have.
You can. You have the next one on the list, menthone, the ketone version.
And how do you define eucalyptol?
Eucalyptol,
How do you define it?
just cool and fresh.
This is what is there in eucalyptus.
It's main ingredient in eucalyptus oil. Yeah.
And then menthol is the
It's actually just fractionally distilled from eucalyptus oil. Yes.
And I've also read, you know, on a few bottles it says eucalyptol 60%, eucalyptol something else percent. What is that?
Eucalyptus 10%.
It says eucalyptol 60%, and then another eucalyptol something else.
Oh, I see. Yeah, that's to do with the percent of eucalyptol actually in the essential oil. So it's like a measure of its quality. So eucalyptol is regarded as like the best part of the oil. So if you have a lot in there, the more the better. Yeah, yeah. And I mentioned something that when I talk about quality control and things. Yeah, yeah.
Can you write Borneo and camphor on the board with the description and maybe make your way salt if you know it.
No, I don't.
And also citra, what do these things mean here?
Sorry?
Like
Where?
citral, for instance, it's got a
Cis. These are connecting. These are isomers.
yeah, no, but what does it mean there then? Soluble, if it's got a line,
Oh, no.
citral.
Yeah, just no. Yeah.
Just means no, right?
Yeah. Just missed. I don't have a proofreader, do I? You don't read. I don't have a proofreader. Yeah. Yeah.
So citral's molecular weight is 152,
Yeah.
and it's not
And
soluble.
not soluble. Yeah. Borneol. Does it make sense? Does it make sense for you? Yeah? It's okay, it's working out. Okay.
Is it okay?
Yeah, great. But are you getting the same results when you smell it?
For the A, not really.
No?
A is not really because mention here is like lemon lime, but after smell is like a bit of fatty,
Fatty, yeah. It's more fatty.
more fatty.
Yeah. The group of these they're called aliphatic aldehydes, yeah, which is from the Greek, and it means actually fat. So all of these are fatty.
Oh, okay.
Yeah.
But just mild notes of lemon lime or orange.
I understand why you think it's mild, but the reason oranges smell of orange is this material. 98% of orange oil is delimited, has not much smell, but the smell comes just from this one material. Yeah.
ก็แค่เอามาแค่เครื่องกับซองครับโอเค
Yes.
On D, these ones, are these already in here, or do
Yes.
we have to
No.
add
They're
on?
basically in there.
They're just in there,
Yeah,
so we
they're
don't have to
they're-
add an extra octa.
Yeah. They're
on
what
there.
I've classed as like
SS
special structures. Yeah. Yeah.
So it is just what it is.
Yes.
there,
Yeah.
it's not-
Yeah.
Okay. And with this
But the idea is you get an idea of the character from the
Yeah.
increased molecular size.
okay.
So some of these, like this one, is designed to show you the difference as the molecule gets bigger,
Yeah.
it gets softer.
Yeah.
Yeah. This one is the difference between aldehyde and alcohol and the terpene.
Okay.
You know, this one is the difference between lactones as they get bigger.
Yeah.
That starts off coconutty
Yeah.
and then gets peachy.
Right. Okay.
Yeah, yeah.
And with this one, do we have to worry about the 2 and the 4?
No, I didn't cover it very well, but it's these dots. These are
Yeah,
the connecting things.
Yeah.
Don't worry too much. It does affect it, but most of the character comes from these
Those
groups.
bits,
Yeah,
okay.
those bits.
Another thing, does this
Yes.
D anyhow affect what you smell?
Yeah, it will do, but it's there's a common one that's talked about D-limonene and not D-limonene, D-carvone and L-carvone. Yeah. D-carvone is dill, L-carvone is spearmint. Yeah. Yeah, but in terms of type of smell, they're not as dissimilar as people say, but there is a difference in the tone. Yeah.
But how do I define the limonene now with the D? How do I define it?
You ignore the D. Most of these just, yeah, like it says there, just, yeah, the twist left to the right, but basically don't take anything into account. Yeah, yeah,
Steve, it might be a the methyl sulfide.
yeah. Oh, dimethyl. Yeah,
Yeah.
it has 2 methyls.
So it has got the D here. Is it dextro here or something else?
No. It's two
Oh,
methyls.
2 methyl. So do we? Right.
So it's more harsh than. Oh right, so you would add 2 of those then?
2 of those, yeah,
So
yeah, yeah.
2 of ethyl.
Methyl.
Methyl.
Dimethyl.
So which is this one.
Yeah.
So that's
So we get 30.
Yeah,
62
yeah,
then.
yeah,
Oh, so it's 30 plus sulfide.
yeah.
And sulfide is S. And sulfide is okay, 32. So 60. All right. 6 or 30, 62.
Yeah. Dimethyl sulfide. Dimethyl sulfide. ตัวนี้บางทีถ้าตัวนี้ต้องจุ่มก่อนไม่จุ่มนานไม่เก็บนานเพราะว่าจะระเหยเร็วโอเคครับ
D stands for
D dextro.
plus limonene.
What does it exactly mean? Stereoisomer twist light to the right.
Yeah, it's exactly the same as left and right hands. Yeah, everything is the same, just differently arranged. So same number of fingers. So what happens is that when a molecule has left and right hand, when light hits it, it twists it one way according to that bond, and it twists it the opposite way. So that's why it's called, yeah. So if you go by vitamin E, for example, it says D-tocopherol, which is natural vitamin E. If it says DL-tocopherol, it's a mixture of 2, it's synthetic tocopherol.
Excuse me. In this case, do I have to multiply
No,
times?
no, just this is position, yeah? If you look at the number, so the ones with white dots on the numbers, don't worry about. So from here, yeah.
Ah.
Position function groups, it's arms, yeah. So
Don't need to
the reason for that is that, let's say this was a molecule. If the thumb was there instead of there, then we maybe that's position 1 and that's position 4.
All right.
Yeah.
There's a table that doesn't have
Can we have the, yeah, group B, group B, please.
Yeah, as soon as you're ready for a group, yeah,
Everyone done group B, yeah?
because hopefully we'll get to J before
Oh, good work.
12.
It's Christmas.
There's only 2 in group B.
Oh, you can have just we didn't have this
Yeah, 3. Sorry?
5.
5.
So if we couldn't do those two because they don't.
Yeah, I wrote it on the board, but you actually can't see it very well because of the light. Yeah.
Why is there only 2 strips?
Oh, because they're the other ones. They're crystals.
Oh, they're crystals.
Yeah.
Could you please explain this?
Yes.
Alpha and beta.
Alpha and beta.
Yeah, what now?
All these things with little connections. Yeah. It's to do with positions. There is a better, slightly longer explanation there. Yeah.
Okay.
What they do. Yeah. So, for example, D and L. Yeah. You saw the D-limonene.
Okay.
The D stands for dextro, which means right.
Yeah.
L-limonene would be left.
Okay.
And it's the same as hands. So that's a molecule.
Yeah.
Everything is the same,
Yeah.
but just the other way around.
Okay.
Yeah. So why it's called D and L is because when light hits it, if it's D, it turns it to the right,
Yeah.
and if it's L, it turns it to the left
Okay.
because of the different arrangement.
Okay.
Yeah. So everything is there, but just in a different way. So all of these numbers, alpha, beta, gamma, delta, L, N, cis, they're all to do with where those connections are.
Okay, so with the iodine alpha and beta, it would be the same, but mirror like.
Well, no,
like that.
alpha and beta is slightly different. It just means that the ketone group is in a different position.
Okay.
But in terms
And
of
do we
smell?
know how that would affect the smell, or is there just you just have to smell it and see?
Yeah, because it starts to get really complicated.
Okay.
Yeah,
So there's no.
if we go into that. But beta generally is fruity, and alpha is usually a little bit more woody.
Right.
Yeah. Like that.
With Nero, 136. Hey, can we grab C?
Sorry?
Can we grab the C group, please?
A C group, okay. C.
We have C?
D-limonene bang ketone jump mai. Chúng tôi name. Yeah. Do I need? Have you got the C one there? Can I just borrow it a moment? I'm just going to redip something.
Just do this till lunchtime, man.
Yeah.
Something another 10 minutes.
Well, in fact, should I do a video before or after?
Do it after.
Do it after, okay.
But what I'm saying is we shouldn't do any more time on this. Just knock it on the head because we're a little bit behind anyway, aren't we?
No, we're fine. We're okay.
Where we up to now?
I'll show you in the book. I'll show you in the book what we're going to do. Yeah. Huh?
What's going on? What have you done here?
I just redipped the lemonade.
Was it right?
Oh, for some reason that one didn't get wet at all. That's weird. So sorry, that's citrus again. I just dipped the lemonade because it evaporated. Who hasn't done citrus? Smelt citrus yet? Citrus? Already? Citrus?
We haven't done citrus.
Oh, you should smell. Do the prediction, then smell, because otherwise you'll be smelling like 50 at one time. Citrus?
Yes, please.
Yeah. Try to just do the prediction of one group first, and then smell them. That way you'll pace your smelling. Yeah.
Did you think it was mine?
It smells like red wine. Yeah.
Rayan. Okay. So for your information. Two o'clock. Yep.
The very last one, which is methyl dihydrojasminate.
Yes.
So methyl 15, dihydrone -4,
Yes.
jasmine +164, plus
Yes.
acetate. Would that be right?
I don't think you need the acetate. Yes. Yeah. It's
Doesn't come
yeah.
up
Yeah.
with
Yeah.
So it's just that.
Yeah.
The pull-out type, not the pull-up type.
Is it working?
Yep.
Are you getting the same as your prediction? You getting the same smell as the prediction? Pretty much. Looks good.
Lactone, right? So
Yeah.
octa, you got your
Yeah.
113. Do we-
Because it's already there for you, actually.
That's what I thought.
Yeah,
So we
yeah,
don't
yeah,
need to
yeah.
add
You don't
up
know, yeah.
113 to
No,
that.
no, yeah.
Okay, so that's the
Yeah,
mixture.
yeah.
So you told me wrong, Francesco.
No,
I've added them all together and got this.
Sorry? You don't need to. I know, I saw you did, but it doesn't matter too much.
Would you use D-limonene for a flavour?
Yes. Well, it is, but it's not.
It's not soluble. So how would you'd end up with an oil ring, wouldn't you?
But well, I mean, most of these materials are not soluble in water. So for flavours, you usually need something there to help it solubilize.
Like propylene glycol or
More like probably a surfactant like tween 20 or something. Polysovic, yeah, or tween 80. The tween 80 is like a bit rancid in its taste.
so there's a tween 20 as well.
There's a 20, 40, 60.
Okay.
And they get more rancid as you go up. Tween 20, it's the least effective.
Tween? I've used it before, but I don't know what it is.
It's a solubilizer. We'll talk about that on Friday. But it's basically a molecule that has a hydrophilic part, which likes water, and then a part of it likes lipophilic, which likes oil.
Okay.
So it acts as like a bridge between water and oil.
So a lot of your flavours will have tween in them.
They have tween or something similar or something, yeah, or maybe alcohol as a, yeah.
You say not to add them together.
Sorry? Yeah, you don't need to.
Oh, you don't need to?
For the lactones, yeah, but that's okay.
Oh, for these ones?
Yeah, for these ones.
How
These
come?
ones you do, yeah. These ones are fine.
How
Yeah.
come not for those?
Sorry?
How come you don't add them
Oh,
for
because
those?
they're as complete units. They're all already calculated. Yeah.
Oh,
think.
I-
Yeah.
oh, I see.
Yeah,
That's-
yeah,
that
they're already.
was that.
Yeah.
Oh, okay.
Citra is always smells like lemongrass.
Yeah. It's 80% of lemongrass is citral. Yeah.
And Nero smells geranium?
It's sort of citrusy, it's sort of rosy. So between rose and citrus.
Has Nero some little flowers from the Bristol lemon tree, isn't it?
No, that's Neroli.
Oh,
Yeah. But probably Nerol is named because it was found in Neroli oil.
right. So,
Yeah.
so Neroli
Yeah.
is the one that's a bit of orange flower.
Yes, yes, yeah, yeah. Sorry?
Doesn't smell citrus, or is it? Smells geranium.
It's yeah, some of it. But my description. What did I write as a description?
Me?
No, for no in here. What did I write? What did I write?
Citrus chemical.
Citrus, chemical, floral. Okay. I find it more citrusy than rosy, but it is a main component of rose oil. Yeah. It's geraniol, citronellol, and nerol, and phenyl ether alcohol are known as the rose alcohols. The main ingredients are rose oil, but this nerol and citral, this is the alcohol, and this is the aldehyde. Yeah. So they're like a relative. One has an aldehyde group, which makes it very strong, and this has an alcohol group, which makes it more soft.
And what is the body?
Sorry?
What is the body?
Body, same as this. It's just terpene. Terpene like that one. Yeah.
Can we have I and J, please?
Yeah.
I don't get the peach from
No?
the octolactone. Sorry, I don't get the
No.
coconut from the octolactone. I get more of an aldehydic, like
Waxy,
waxy.
fatty character. Yeah.
And then
Because this is interesting because who was it? Didn't get they didn't get the citrus character from the aldehyde C8.
Right, okay.
Yeah, but that's what I said about this. Like it's a smell, and it's that octyl note is metallic, but some people immediately smell it as coconut. Yeah, some people immediately. Then the yeah.
Yeah, that's what I thought. And then the decalactone, I got really peach, but then the undercalactone went back to that waxy fatty for me.
What do you mean by heavy aromatic?
Do you drive? When you go into a petrol station, that smell of the benzene and the that heavy, really heavy smell.
Would it be a smell of kerosene?
And more the like hexane and well, not hexane,
Diesel?
octane, yeah. They use, yeah, or benzene, yeah.
So that's what you smell in the petrol station.
Station,
that's
yes, yeah,
what-
that heavy, that really heavy character. Yeah.
Yeah, but not so much no, I smell more friction.
Okay. Have you smelt? Where are you up to?
We smell to feel. We have to smell here.
There's their fruity notes. Okay, get some fruity notes. Fruity, fruit. Okay, interesting. Okay. Mi ben hagap song donika rahoi rail. Maybe I to Yeah, maybe now. Amyl acetate. Amyl acetate and amyl acetate. Okay.
That's pretty soft. I can't get much of that. Quite soft, no? Like it's.
Give me a tissue. It's helped it a little bit.
Yeah.
Yeah.
Wow, it's more fruity now.
Yeah. See,
This one's called the
that's the difference between smelling from a bottle and smelling from a smelling strip.
hexoacetate fake green apple shampoo. Is that what they use? The green apple hand wash and all that sort of stuff?
Yeah,
It exactly reminds me of that.
yeah.
It's cool.
Oh, hexoacetate. Two the same. Are you ready for fruity yet?
They're not even palatable yet.
Fruity? Are you ready for fruity yet?
I don't. We've kind of been steaming ahead, so I guess.
Save a lunch now.
Yeah.
This is really important to fill in. So the base is basic
We've
maths.
missed out a couple
That's
in the
right.
middle. We've missed out
Yeah.
DNA.
See, I don't get the coconut in the C8. I don't find coconutty.
Why not? Oh, what? That's the wrong one. That's not. Sorry, that's wrong. That's not. Oh no, sorry, that's aldehydes.
That's what I was thinking.
Hey,
That's aldehyde.
they've- that's aldehydes. That's not lactones.
That's what I was thinking.
Yeah. Yeah.
That's also.
So the 9, 10, 11
That's been sat on top of one, Stephen.
Yeah, it's been contaminated. Sorry. Can I smell your? Do you have any the lactones? Can I have a quick smell because we might have a problem.
This one's alright.
No, it's not. That one's okay. Yeah. Oh, but that one. There's something wrong.
With this one?
Let me go. There's something wrong here. Shit. What's happened here? Lactone.
2 seconds. 2 seconds.
No, that's aldehyde C8. That's aldehyde C8.
Come on, collect on C8.
No, they've brought in aldehyde C9. That's aldehyde C9. That's okay.
I thought Dan would have known.
No, that's aldehyde C11. Okay, we have a technical problem here. Forget the lactone samples you've smelt. Yeah. Yeah. Forget the lactone samples you've smelt. Yeah, we've got some contamination. So we'll arrange some fresh samples later. Yeah. Sorry about that. Lactones. Your notes from the book should be okay, yeah, but when you smelt and compared them, there'll be some mistake. So I'll try and get that sorted out this afternoon. Yeah, believe your nose. Don't believe me. Yeah. Some of the things that go against shape theory, the idea that there are some things that we're anosmic to. So John Moore's argument for shape is that we're anosmic, which means we can't smell a particular molecule, yeah, because we don't have the receptor. Yeah? So if it was vibrational, surely we should be able to smell every single smell. So that's one of the things that goes against vibration. Yeah. Another thing is that, which comes out in the longer video, which is the original Horizon program, the BBC Horizon program that we show next week or the week after. And there's an example that's given of L-carvone and D-carvone. And D means that it's like what they call stereoisomer. The molecule is made up of the same components, a little bit like our hands, but it's just the other way round. So D carvone bends light to the right, yeah, and L carvone bends light to the left, yeah. One D carvone smells of dill, L carvone smells of spearmint, and if vibration was the only factor, yeah, then both of them should smell exactly the same. Yeah, but with D-carvone, there's some indication that when it enters the receptor, the ketone group doesn't get to the receptor the same way that the L-carvone does. Yeah, so that sort of supports the idea of shape. Yeah, so I actually believe there's a shape factor and a vibrational factor that come into it. Yeah. Okay. So, Prel, can you call? Yeah. Prel will give you the lactones again. Yeah. Have a quick sniff of those, and then go on to page 2, and then we'll continue with page 2 until 3 o'clock. So try and do these fairly quickly. So if you go to page 2, already there. Wow, halfway through. See, this guy's already finished page 2.
So it's terpenyl.
Yeah, harsh chemical pine floral.
And then the ol being the alcohol.
The alcohol, yep.
Would the E make any difference? It's just the link, yeah?
Which is the link, yes.
So would that mean, so this is harsh chemical pine floral and the alcohol makes it softer. So would that make it less harsh? Or
Yes, makes it less harsh.
So it's actually wouldn't be a harsh chemical pine floral, it'll be slightly milder
Yeah,
chemical
yeah,
pine
yeah,
floral.
yeah.
Or does it make that much difference, or is it? Would
No, it makes a lot of difference.
Consider it mild, so rather than harsh, or is it two different things?
It's comparative to that structure, because sometimes when I talk about soft, if I talk about amyl acetate, yeah, it's like fruity and fresh, yeah? The amyl alcohol is actually really, really choking.
Okay.
But compared to the alcohol in terms of impact, it's a lot lower.
Okay.
So sometimes when it's soft, it's not really, it's not soft, it's comparatively.
Than it was without it.
Yes, yeah, that's it. Yes.
If it's linalool,
Yes.
so Lena is no for water soluble.
The linalool has an alcohol group.
Yeah, so
Yeah.
linalool is no, but OL is yes, so yes becomes dominant.
So it has a, yeah. No, so dihydros, yeah, dihydro, ditetra, yeah, di is, particularly these ones, yeah. Hydroxy is with an OH group, but dihydro is not an OH group. It just means less hydrogens, less 2 hydrogens.
So when we're doing the calculation, you've got myrcene, which is 136.
Yeah.
Alcohol, which is 17. So it's that plus that minus 2.
Yeah. Something that's easy to get confused with is hydro and hydroxy. When you get dihydro actually it's nothing to do with a alcohol group. It means less hydrogens. Yeah, and tetrahydro is less hydrogens. Hydroxy is the only one that has the alcohol group. Yeah. Make sense or? So dihydro means less two hydrogens. Not more, no. No, I know, it's a strange way. Yeah, that's right, you lose a double bond, yeah, basically. You have a double bond in a molecule, and you take off one hydrogen, minus one hydrogen, so you get a double bond. Yeah, you get a double bond, yeah, you get a double bond. Yeah. I don't know if this is too much information, but if you imagine that a single bond like flaps around on its own fairly loosely, but then when you get a double bond, you get like quite a high vibration because you get tension between the two bonds. And so when you get a double bond in something, it tends to make it a little bit fresher, a little bit more vibrant in the smell. But hydroxycitronellol, yeah, is almost odorless.
Right, okay.
Yeah, because you've got
And
the
so-
alcohol and the hydroxy group.
So you've got the hydroxy group. Okay, so the molecular weight being 13, so it's lower, so it will have way more impact.
It should have, yeah.
Hydroxy.
Yeah, yeah.
And it's very, very water soluble.
Yes.
But overall, does that mean it is?
It is water soluble. It is actually water
So
soluble.
the yes,
So it's
the big
water-
yes overpowers anything
Yeah,
else in the
yeah,
group
yeah.
that's got a no.
Yeah, yeah. But it's dependent on all the other factors. So it's yeah.
So the hydroxycitronella is lighter,
Yes.
softer
Yeah.
than the citronella.
So if you compare to the citronellal, have you smelt it yet?
Yes, I'm smelling
Yeah.
But it doesn't
Citron-
smell rosy. It smells like, citronella.
Lemongrass, yeah.
Yes.
Yeah.
But lemongrass has got a slightly rosy note to it, though.
Well, citron.
I never felt like that.
Maybe.
So it's rounder than a citrus.
Let me smell it. No.
Lemongrass can have quite sugary kind of.
Yeah, it's got this is citronella. It's got the sharpness. It's got that sharpness, the same sharpness as in citronella, citral.
Yeah.
Yeah, but it's a little bit flatter than the citral. Do you remember the citral?
Yes, yes.
Yeah. And that's the rosiness that I'm talking about. A bit like the difference between nerol and citral.
Okay.
Yeah. But you have to feel it to. No. Yeah, we get down. Max. Oh. Tabard. N group is a powder and a liquid. N group.
Steve, while you're here,
Yes.
Jasmonate, that 8 ending, is that
Page 1. Page 1.
Getting worried about
acetate or benzoate?
Time.
Butyrate?
This is N.
Which
Sorry?
8 is it?
Sorry?
Which 8?
Which one?
Jasmonate, which 8 is it?
Oh,
Acetate, benzoate?
jasmone. It comes from jasmone.
Yeah, but doesn't the 8 mean anything?
Just that.
ATE?
Yeah. Just imagine it as the connector. Yeah, heavy
So it's
jasmine.
like
Yeah.
YL.
Yeah,
like
yeah,
ill.
yeah, yeah.
So
Because
8
it's
also
where it's
means
like
connected.
esters, like butyric acid becomes butyrate
Isn't that because it's coming from...
from an acid. Yeah,
from
but
acetate?
yeah, but this is not really from an acid. So
Okay.
yeah. Ready? Fit in? I think you should be. Citral. Should I get rid of some of these?
How should I go with the last one?
The hexa, the deca, and the lactone. Hexadeca means 16.
16.
Yeah.
Hexa, green, right?
Yeah.
85.
Hexadeca, and then needs this one. So just let me look at the whole sheet. This one here.
Pentadeca.
This one.
This one, right? 240.
Yeah, but it's actually got another. Yeah, there's a bit of a. It's a musk. This one is a musk, but it's got one more carbon than this, so it's a heavier musk even than that one.
Okay. So how should I go about it?
So this would be, the molecular weight would be 240 plus another 12, another 14 hexadeca
240
plus
12
12 for another carbon and plus another 2 hydrogens plus 2.
plus 2.
Yeah.
I don't find the jasmine in the Indo.
No, I know. I can understand that. But if you get jasmine flowers and you put them in a room and you go away for the day and then come back, this is the smell that hits you. Just pure indole.
Because jasmine is like really heavy and very, very warm.
The heaviness is
The
this.
heaviness
Yeah.
is there. I feel the harshness, I feel
Yeah.
the warmth. It's a little floral, but I don't see the narcotic jasmine in it.
No.
But that's because, like you said, you gotta leave it for.
You leave
time
it.
and then-
You know the petals of the jasmine will go brown on the edges, and most white flowers go brown
Yeah.
because of indole. This changes colour.
Okay.
But sometimes I didn't see it until one day somebody was drying, you know, for the garlands, so somebody dried some flowers in our house. And I came back at the end of the day and it was like, oh, it's like pure indole. Yeah. When the girls make the indole solution in the shop, sometimes they like run out of the shop because it's just too strong. I can't smell. Oh, well, you can't smell benzoyl salicylate. Yes, you can. Yes, you can. So how about galaxolide? Faint. I can't smell galaxolide, but benzoyl salicylate is quite strong for me. Yeah. Yeah, but it's like a citronella, yeah, and this makes it water soluble, so it has a very soft odour.
I think it's like boil lemongrass. Huh?
Any benglum nung, any nunglum, any nunglum. Oh, okay. Oh yeah, my P, I got my high, okay. High low P. P. P.
Can you help about cinnamate and
Cinnamate.
Yes, cinnamate.
Cinnamon?
Yeah, same thing. You see, it's exactly the same description.
Ah.
Oh yeah, sorry, that's cinnamon.
There's a mistake in the molecular weight.
So the cinnamic and the cinnamate, is it cinnamate or cinnamol? Like the same thing, really. So
What it is to do, one is the body, so you get cinnamyl acetate, and then it can also act, this same group can act as a functional group, so you could get ethyl cinnamate. Yeah, to take two positions. Did you do the orchid ones, or are you doing the orchid ones now?
Okay.
Benzoyl salicylate, could you smell?
No.
No? Yeah. So, 50-50. 50% of people can't smell it.
But cannot benzoyl salicylate.
Yes, yeah.
So it's regular.
It's quite common. It's quite common. Common to find people who can't smell it.
That's what I'm asking for smell.
Is this paracetyl phenol acetate?
Yes.
Smell a bit medicinal, bit honey.
Yes.
But the medicinal is quite mild.
Quite soft. Yes. Because the functional group usually overpowers the body.
Usually.
Yes. Because, like I said, like my body, although it's the biggest part of me, it does less interaction with the world.
Okay.
Yeah. So the phenyl acetate in this case is the functional group, so it has more effect on the smell than the paracrete or the body.
So meaning.
So the honey overcomes the paracresol.
Okay.
Yeah. Rose group, first group. Rose. Rose, the first group. First rose group. This one, yeah.
That's why I said to him, get the contact seeds.
It's okay. ไม่มีปัญหาแต่ว่าแค่ไม่หอมปกติรู้สึกหอม Okay. Get the pressure on. Woods. Yes.
It smells a little bit like it's got a bit of a salicylate.
Yeah. Actually, if you look at the structures between the NO and P, they're actually very, very similar in structure. Yeah.
Indol.
Indol.
Indol, no?
Yes.
So this is OL. Includes
No.
alcohol?
Yeah. No, it's not. It's not. It's just.
Right here,
Yeah.
no.
No. Yeah.
So this is different.
It's different. This one's different.
I mean, this
The
word is come like
the indol is the common name for it, but the chemical name is a lot longer, and but it's not really an alcohol, I don't believe. Yeah. But it smells very
no also.
yeah. The main smell, it's the main smell in jasmine and white flowers and feces. You understand me? Feces?
This is
Toilet, yeah.
Everybody is
Maybe.
Do you use vetiver acetate much in Perfumery?
Not nowadays, because it was always a favourite to use, but the problem is it's not very stable, and after a time the acetic acid splits off and causes irritation. Yeah, on the skin. Yeah, yeah,
Quite a cool smell though.
yeah,
Quite beguiling.
yeah. And also because vetiver has become so expensive, the acetate version of it is like $500 a kilo, and it used to be like 60. Yeah.
I'm confused by the last one.
You know, oh, you didn't hear me say. I said, sorry, I didn't put the hexadeca, but it's like the pentadeca. It's similar, but it's an extra carbon. Yeah. So you have to add 12 on for carbon and two for two hydrogens. Sorry about that.
is EN and E the same?
ENE indicates there's a double bond. Yeah?
No, but how do you see? You mentioned ENE here.
Yes.
And here we have just the EN. So, you know, this gives us the green note.
No, yeah, it is the ENE. Yes.
It's the same.
Yes, yeah.
So this will be more greener, more fresher.
Yeah,
And the lactone would be a little peachy and oily.
Yes.
So green, peachy, oily.
Really green.
But sorry, it's not hexa. It's hexadeca, which is 16.
So it's not
Yeah.
green, so what's hexadeca?
Hexadeca, because it's such a big molecule.
Yeah.
Yeah. It's pretty soft. It's very soft. Yeah.
Because I'm thinking of ambretolide is not, I mean, I know...
It's not green. Yeah.
No,
It's not green
it's
at all.
like a musky
Yeah. Because it's such a big molecule, it's very soft. So you get that gives you the muskiness, and with the lactone.
Yeah.
You remember I said about the link between D and X?
Yeah.
Yeah. D is the smaller lactone molecules, and when they get bigger, they become musky, like human skin.
Yeah.
And that's the hexadeca. Yeah.
So is ambretolide something, because I can't smell galaxolide.
Me neither.
So I don't actually know what it, I can't, is it similar to ambretolide or?
Yes, yeah.
Because I can smell ambretolide a bit, not much, but...
They're similar, but it's interesting, even though you can't smell them, you may find the same as me. I can't smell them, but when they're in a compound, I can smell the effect of them. And I liken that...
It gets taken out?
Yeah, you can, yeah. Because it's like a piece of glass. You can't see it, but when something's behind it, you smell the distortion on the other materials.
Okay, and then when you take it out of that...
Then that distortion is not there.
So then you... Okay,
Yeah,
I've never tried that, so
Yeah,
that might...
It's the same as like benzoyl salicylate. Could you smell that one? Yeah. 50% of people can't smell it. Quite common.
Was it the benzoyl that we were talking about? Yeah. It was the one that I felt was a little bit...
That is butyl.
Oh, was it butyl?
Butyl is... Yeah.
So benzoyl I can definitely smell,
Yes.
I'm having trouble with the exaltalide, and I
Yeah.
don't know if I can smell anything.
That's right. It's normal. If you can't smell galaxolide, it's very likely you won't be able to smell exaltalide.
Okay, but I can smell the ambretolide.
Ambretolide.
Yeah.
A bit more animally.
Yeah, musky, like
Yeah.
woody kind of.
Yeah.
Kind of
Yeah. Oily.
A little bit, yeah.
Yeah.
Very,
Yeah.
very
Yeah.
mild, hardly
Yeah.
anything.
And the exaltalide's a little bit fresher.
So I can't. It's like there's nothing on the
Yeah.
thing.
But if you gave me six of these musks on a smelling strip, the chances that I could actually identify them is very, 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 very low.
See, I've got about 5 or 6 different
Yeah,
musks
yeah,
at home
yeah.
that I try with,
But when you try them in the compound, then you see the difference.
Right.
Yeah, yeah.
Vanillide as well I struggle with a bit.
Yeah, I mean that's a bit like galaxolide in the sense of a cross between tonalide and...
But I wear really hard poison, which I really, really like, but apparently there's a lot of vanillide in that.
Yeah.
come back. Yeah, no, I'll come back.
But maybe if it wasn't, I don't know.
I'm sure you would. I'm sure you would. It's have you seen What the Bleep?
I haven't, no.
Oh,
But I
okay.
do go.
But I was going to say about the story of the ships on the sea. The Aztecs couldn't see them,
Right.
and then the shaman went to the beach every day, and then noticed the ripples were strange, and then noticed the ripples around them. Yeah, and then could see the ships.
Right.
Okay, because he'd never seen ships before, so he didn't know how to identify them. But by seeing, he knew the sea and he knew the ripples on the sea. And it's the same thing with the musks in the perfume. You see the effect around it.
Yeah. So you
Yeah.
know what to look for once.
And then suddenly you say, oh, okay, so I can't really see the mask, but I can see what it's doing to everything else. Yeah.